Okay, everyone, welcome back. We'll start our other unit here on polynomials. We just finished looking at real numbers, and now we have to talk about polynomials. So you would have talked about them in grade 9 as well. We obviously go a little bit more in depth here for grade 10. So a polynomial, you see an example up above. It's going to be a combination of constants and variables with whole number exponents. And remember, we did talk about whole numbers before in our last unit when we talked about number sets. So there's a whole number exponent, so you're counting numbers starting at 0. It can be combined using addition, subtraction, multiplication, but not division. So we will talk about division in a future course. When we talk about division of polynomials, this is going to be what we call a rational function. Okay, not a polynomial function anymore, but a rational function. So you have a couple examples of things that are polynomials and are not polynomials. We need to define a couple words here first before we get going. So we're going to use these words all the time in this unit to talk about things. So it's helpful to know what they are. So a coefficient is going to be a numerical constant. Numerical constant. That multiplies a variable. Okay, or it could be just a general term as well. So an example of that would be something like 2x cubed. The coefficient is 2. Okay, so there's our coefficient, our number before our variable. Now, a leading coefficient is something a little bit different, and that's going to be the coefficient of a, let's say, for now, let's just say variable with the largest exponent. So in a polynomial, we could have multiple terms, poly meaning many, nomial meaning term. So we could have multiple terms. Now our leading coefficient is going to be the coefficient of the one that has the biggest exponent. Our constant is going to be the term with no variable. Okay, and those are just going to be your numbers. Usually they're tacked onto the end. So when we write a polynomial, we usually write them in decreasing order of power. So the exponents will get smaller and smaller until it's really x to the power 0, which you learned before was just 1. So a term is going to be, it could be variables. Actually, sorry, I don't want to say it that way. Let's say it is a single number variable or numbers and variables multiplied together but they are separated by addition and subtraction. Okay, but separated. I'm going to run out of space. So they are separated by addition and subtraction. You won't see a term separated by multiplication or division. Separated by addition or subtraction. And we'll talk about a bunch of examples down below what different terms could look like. So here's one. So let's do it up here. So here's an example. A term could be 2. A term could be 2x. A term could be 2x squared. Each of those are terms. Okay, notice that the 2 and the x, they're multiplied together, so we take the whole thing to be one term because there's no addition and subtraction here. If you're going to classify a polynomial based on the number of terms, this is where the next couple words come in. So a monomial would be a polynomial with one term. A binomial, that prefix in front of nomial meaning 2, so that's going to be a polynomial with 2 terms. And then trinomials are the important ones in this unit that we get to for Math 10. That's a polynomial with 3. Yes, let's keep it consistent. Write the word 3 terms. Okay. If you want an example for each of them, so here's an example of a monomial, 2x. Here's an example of a binomial, 3x plus 2, 2 terms. So the 3x counts as one term, the 2 counts as another term, separated by addition. Now your trinomials are going to always have, well, I guess I shouldn't say always, but for us, most of our important trinomials are going to have something being squared. So like x squared plus 5x plus 6. Okay, there's a trinomial. Now degree is something that you might have touched on in grade 9 or you might not have. Now a degree is going to be talking about the variable's exponent. Okay, so if I have x squared as my term, the degree of that would be 2. Okay, so we'll just take the variable's exponent here. But if there's more than one variable, so if more than one variable, we take the degree to be the sum of exponents. So for example, if it's x squared y, the degree of that is going to be 3. Okay, we'll take the degree of the x, or the exponent on the x, the exponent of the y, add them together. So the degree here is 3, sum of those exponents. If it was just x squared, the degree would be 2. Okay, now the degree of our polynomial is going to be, how should we word this? That's going to be the highest degree of one term. So for example, if you have a polynomial that looks like x cubed plus 2x squared plus 3xy plus x, if we look at how many terms we have, this polynomial's got 4 terms. Now, for the degree of this polynomial, we're looking for the highest degree of a term. So our last term here, x, has a degree of 1. Our 3xy has a degree of 2, because we only care about the ones on the variables. Our 2x squared, also a degree of 2, but our first term there has an x cubed. So this polynomial would have a degree of 3. Okay, so we're just looking for the highest one on the terms that exist. Okay, so just a couple definitions before we get going here. Okay, so our first example asks us to classify the following expressions as polynomial or not. Okay, we'll talk about a couple of things that happen here. So for A definitely is a polynomial. Since I've got, 2 different terms, they're separated by addition, subtraction. My x has a degree of 1. So this is a very, very common polynomial function we classify as linear. Okay, so that is polynomial. For B, if I look at this power, that -2, that -2 is not a whole number. So if I think back to how the very first thing we talked about, a polynomial is a combination of constants and variables with whole number exponents. So from 0 and up. So no negatives in whole numbers. So for B, since that exponent's a negative, this is not polynomial. Not polynomial. For C, also could see that could be a polynomial function, because if we're looking again at our definition, combination of constants and variables, whole number exponents, combined using addition and subtraction. So here, that one would be okay as a polynomial, because our root 5, even though that's not a whole number exponent, root 5 could definitely be a coefficient of our x squared. So this one, polynomial. Okay, and we can try graphing it as well. So I pull up my calculator here and show you what it looks like. Back up. There's the calculator. Okay. So square root 5, close the bracket, and then x squared. And where did it go? Oh, I gotta put it here, that's fine. Square root of 5, and then multiply that with x squared. Okay, so definitely a polynomial function. This one you'll see more in Math 20. We call it a quadratic function because of that square. So that'll come a little bit later, but this is definitely a polynomial. Okay, the root 5 in front basically just acts like a coefficient. Okay, we're writing it in its exact format because it'd be around a decimal. So this one, totally okay. For D, this one is what we would call a rational function. So we'll see what it looks like. Now for the graphs, you don't really have to be concerned with them in this course. It is just interesting to see what they look like. So there's math cubed. You'll see it looks very different. Okay, so we've got kind of a heartbeat shape here almost. So this one would not be considered polynomial because we're dividing. Okay, so we're dividing that variable on the bottom. Okay, so not polynomial. This would be considered rational. For E, you've got whole number exponents. You have a constant on the end of 0.5 or 1/2. This is definitely polynomial. And likewise, so is the last one. If it's just 7, that's a one-term polynomial. Monomial, it's just a constant. That's totally okay. Okay, if we take a look at the table down below, we have a couple of them. So we'll talk about all of these things. Maybe we won't do all of them, so I'll do maybe 3, I think. So we'll do this one here, we'll do that one, and again, we'll do this one. And we'll leave the 2 in between for you to try, so you can check the answer key and fill them out. Number of terms, there's going to be 2 terms in this one, which makes it a binomial. Okay, 2 terms, binomial. And let me make sure I'm doing that part. Yeah, okay. That's binomial. Degree comes next. So we're going to look at each individual term and add up the exponents that are on those variables. So our first term is 4x. It's got an exponent of 1. The y and the z each have an exponent of 1. So the degree of this is 2 because I'm looking for the highest one. Okay, so this is the one that's going to dictate that degree for us. Now, if I know that, my leading coefficient then has to be 3. Okay, because it's on the term that's got my biggest powers. Okay, my leading coefficient is 3. A constant, I don't have one, so it's 0. Okay, so you really could technically have a, let's erase that, I could have a plus 0 on the end. So there's my constant. Number of terms for this third one, there are 3, which makes this a trinomial. Degree of it, again, you're looking for the highest exponent power, so that's going to be 2. Degree 2. Leading coefficient of 1. In front of that x squared, there is a 1 sitting there. So there's our leading coefficient. Constant here, 7. Okay, last one, the number of terms. I see 1, 2, 3, 4 terms in this one. Classification, as soon as we get more than 3, we'll just call them polynomials. Okay, so it is a polynomial. Okay, whole number exponents again. Degree of this, highest one I see is going to be a 3. The coefficient of that term is a 2. And our constant this time is actually -8. Okay, so it's subtract 8 in that polynomial, so -8 is the constant. Now I know last year that a lot of people did talk about algebra tiles, so they come back here as well to help illustrate some new stuff. So all of the positive ones are going to be shaded. The unshaded ones will be negative. So we'll keep that legend going. And we'll do a couple things down below. So we're just going to actually take a read through this picture to see what polynomial we have or don't have. So shaded are positive, unshaded are negative. So for A, the squares, actually we'll say what they are up top. So the squares are going to be your x squareds, so that's a -x squared. The bars are going to be either your x's or -x's. These are your 1s or -1. So these will allow us to do everything we need to for polynomials. So here, that means we have a -x squared plus 3x's plus a 1 on the end. So everything kind of matches up. For b, you have positive 3x squareds. Now for the x's, you had an idea before called zero pairs. So if I have a positive x and a negative x, they cancel out. So I don't really have any x's. I don't even have to write that. Now for the ones, you see that 1 and 1 cancel, a positive and a negative. So really, this is 3x squared plus 1. Okay, so by canceling some things out, we can write it a little bit simpler. Okay, we'll maybe talk about just one of these down below. And I think we'll just do b here, because this part is relatively straightforward compared to what you learned before. So use the algebra tiles to represent the following. So I need to have -5x's. So those ones are unshaded. 2, 3, 4, and 5. And then positive 3. 1, 2, 3. And again, those, if they're positive, should be shaded in. So just taking a read through that polynomial and representing it in tiles. Now the multiplication part, much more important for what we're going to do coming up in this unit. So I'll take a couple of them. And again, I'll leave you A, C, and D so you can try them. I'll fill them in for the answer key. Now these are the last ones we'll take care of anyways. So I'm going to do C and D. I'll let you try B. Now for C, we are really dealing with multiplication. So we're going to create what's called an array for us, a multiplication array. Now along the top and the side, we really give this a name called the area model. So basically we're going to think about those polynomials as having a length and a width, because inside it's going to create a rectangle for us. So one of our pieces, one of our dimensions is going to be 2x's. It doesn't really matter where you place it, so draw it here. So there's an x. There's an x. Now they should be positive, so make sure you shade them in. That's going to help with the signs later on. And along the top, we'll put our x plus 3. Now, we really need to make sure that we match up the dimensions here. It's not a good rectangle. So the dimensions are going to be important. So what I mean by dimensions, make sure you kind of lay them out the same way. So I don't want to have that one vertical along the top. 1, 2, 3. And when you go to fill in this grid, this is where you're going to match the dimensions. So in each of the spaces, you can kind of organize the grid like that. On the inside, you're going to match up the dimensions. So on the left, I've got 1x. Along the top, I have another x. So if I actually fill that whole thing in, that space is going to make up an x squared. Same thing underneath. X squared. Okay, for the other pieces, you're going to see it's an x on the left by a 1 on the top. So that shape that fits is another x. And you can see the same pattern happen all the way throughout the remaining ones. And we'll shade those all in because they should be positive. Okay, so there's our final answer using algebra tiles. So the polynomial this actually creates is, now I have in purple 2x squareds and 6x's. So plus 6x's. So there's my answer when I multiply. Okay, we'll do one more as well. We'll do D. And we'll create our grid for us again. And we've got 2x's and a plus 3. 1, 2, 3. Shade them in. And our 4 is along the top. And also shade them in. Okay, so now we're going to match up all the pieces. So we're going to have an x here, and x here, and x's all the way down. Sorry, they're starting not to look like x's. Those are x's inside, and they are all going to be positive if I remember my integer rules. for multiplying. Go. And then all the way across, I'm going to have 1 by 1s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there is our multiplication grid, our area model for this. So the reason why we call this an area model is because really it's a length multiplied with a width to give us a whole rectangle. So if you imagine taking all those tiles and squishing them together, they'll always create for you a rectangle. So the polynomial that represents is 8x's plus 12 1s. 8x's and 12 1s. So there's your quick review on polynomials. So in our second lesson, I don't even know what we're going to take care of. Let's just, in our second one, we'll take care of multiplying those polynomials. We'll probably stop using that area model there as well, which is kind of nice. So take a look back later. For the second one, you'll probably see it linked at the end here. And you can just click right into that one. So we will see you next time.